Oh. All right, so I'm going to try doing this from home. So I want to talk about inverses. Sorry about the other day. The sound did not come through in the recording, so I want to go over inverses now. And well, let's talk about inverses. How do they work? Well, the idea is this. We have an input x. It goes into a function f, and then you get an output y. So the question we want to answer is this. Can we take y and recycle it back into x? And you could sort of call the recycling center that does that is F inverse. So F inverse will take y as an input and give you back x. So I want to talk about how do you know two functions are inverses? And this goes back to compositions. And there's a rule for compositions. And it works like this. If f of x and g of x are inverses, then the following happens. Now, what I mean by inverses is that if you take x, it goes into f, and you get y. Then if you put y into g, g will give you x again. So g plays the role of f inverse. So this is actually true if the following is correct. If f of g of x, and that's, in other words, wherever we see an x in the function f, replace it with g of x. You just get x. This also has to be true if x in g of x is replaced with the function f or f of x. Well, again, you get x. And both of these have to be true, not just one or the other. So let me give you an example. Let's say f of x equals 3x plus 1. And g of x, let's see, is x minus 1 over 3. Are these inverses of each other? Well, what we do, we take f of x, replace the x with the entire g of x. So that means we get 3 times g of x plus 1, or 3 times x minus 1 over 3 plus 1. This is your g of x. And there's some cancellation going on here. These 3's will cancel. And we'll get x minus 1 plus 1. These will go away, and sure enough, we get x. Well, we're only halfway through. We have f of g of x, and that worked out. We've got to check g of f of x. So replace the x in g of x with the entire function f of x. or 3x plus 1 minus 1 over 3. And then we got our 1's canceling out there. So we get 3x over x, I'm sorry, over 3. And sure enough, that also gives you x. So since both of these give x, f, g, they're inverses of each other. So that shows that they are. So how do you find an inverse? Well, one way we can find an inverse, well, there's a certain procedure for this. So finding f inverse of x. Well, the first thing we do is we'll take our f of x. We'll have some function f of x equals something. And we change it to y. This just kind of makes things easier. Then we exchange x and y. So what that means is the x in our equation will become a y. The y in our equation becomes an x. Then we solve for y. And then once we solve for y, we relabel y. We now call it f inverse. So those are the steps we're going to take to find the inverse of an inverse function. All right. So let's do an example. So let's say we have something like this. Well, first off, number one, we change f of x to y. And there we go. And number two, we swap x and y. And there we go. Y became x, x became y. That's step two. Step three, we solve for y. And so there we go. Finally, we change y to f inverse of x. And that's our answer. And so that's how you find an inverse. Now you have to be careful with some functions. A function that's not going to give us a problem would be, say, something like this. F of x is x cubed. Change f of x to y. we get x cubed. Make the y x, make the x y. And then we solve for y. So we have a y cubed, so we need to take the cube root of y cubed and the cube root of x. And so we get cube root of x equals y. And then finally, we say f inverse of x equals the cube root of x. And there we go. That's our answer. And here, let me do one more. Let me do a slightly more complicated one. So again, we change f of x to y. Swap them. And then solve. And so what we'll get So what we want to do is we want to get the y's on one side. So I'm going to subtract 2y from both sides. And then add 4x to both sides. And then factor out y here. And then divide both sides by x minus 2. Put 4x plus 1, x minus 2. And then finally, f inverse And there you go. So that's your answer. Now I want to talk about something with inverses, and it has to do with coordinates. And I want to go back to this one. We found out that the inverse to x cubed is cube root of x. So what this means is if we think about the coordinates for f of x equals x, let's say we take -2, -1, 0, 1, and 2. This will be our x and our f of x. Well, we cube each of these. -8, -1, 0, 1, and 8. Now for this one though, since it's the inverse, these become the inputs. In this case, we let x be, let's say we choose, or just say we chose these as the inputs, -8, -1, 0, 1, and 8. Cube root -8, you get -2, -1, 0, 1, and 2. Now, I kind of gave it away a little earlier here, because the point of an inverse is the inputs and the outputs. Well, for a function f, x goes into f, and we get y, but then y goes in the f inverse, and f inverse puts out f. So if we look at the top part of this, x is the input and y is the output. But for the inverse, it's switched. What was y is now the input, and then x becomes the output. And here you go, here's our inputs and our outputs, and so they just switch places. So what this means is this. Let's say you have the ordered pair -2, 8, or -8 for f. Well, that means the inverse will have the ordered pair -8, -2. So the coordinates switch. So in this case, x is now y, and y is now x. So this has an important graphical consequence. If we graph a function with its inverse, so let's say we have x cubed, it looks something like this. Well, x to the 1/3 looks something like that. And what we're going to find, now this line I just drew, this is y equals x. And what you see is these functions, they're symmetric along that axis y equals x. So In other words, f of x, and here I better label these functions here. This is f inverse of x is the cube root of x. This is f of x equals x cubed of x. So what we find is f of x and f inverse of x are reflected, or reflections of each other, excuse me, over y equals x. And this is a consequence of switching the coordinates. So here's xy on f of x. And here's yx on f inverse. If we start out with this, we'll have this, and they're reflections across of each other across y equals x. So just an interesting consequence of the fact that we're swapping the coordinates to get the inverse function. There's one last thing to mention with inverses. And I mentioned a little bit of care with, I might have mentioned some care with x cubed. It's not really x cubed, it's this one. So we get y equals x squared. So we go through our steps. So already had it as y, let's say is f of x. Step 1, make f of x into y. Step 2, swap them. Step 3, solve for y. And so we take the square root of both sides. Now, when we take a square root like this, we got to be careful. We're actually taking the positive, we're looking for the positive and negative roots. That's not something we do with cube root. Cube root, we just take the cube root of something. So if you take the cube root of -8, -2 times -2 times -2, multiply together 3 -2's, you get -8. So that means the cube root happens to be -2. But you take the cube root of 8, 2 times 2 times 2 gives you 8. Multiply 3 2's together, you get 8. So that means the cube root of 8 is 2, because it takes 3 2's multiplied together to get 8. 3 -2's multiplied together gives you -8. Cube root, we don't think about plus or minus. It just kind of shows up if it shows up. Sometimes it does show up negative, sometimes it doesn't. Square root's different. And the reason square root's different is if you take -2, you square it, you get 4. -2 times -2 is 4, but also 2 squared equals 4. So that means the square root of 4, well, 4 could have come from plus or minus 2. Could have multiplied a couple positive 2's together or a couple negative 2's together. So when we take square root, we have to consider square root x equals y. And so what does this mean for our inverse? because we're going to say that f inverse of x equals plus or minus square root x. But there's a problem with this. Let's try graphing it. This is an inverse, but it's not a function. So we found an inverse, but we haven't found an inverse function. So what happens? We graph y equals x squared, or f of x equals x squared. We get something like this. Now, if we graph positive square root, we get this. We graph negative square root, we get that. So here's where we have f inverse is the positive square root. F inverse is the negative square root. And then over here we have our function f of x equals x squared. The problem is this. If we use the vertical line test, this inverse fails. Like, say, for example, this was x equals 4, this was negative 2, and this was positive 2. So if you have an input of 4, should you go up here or should you go down here? In other words, f inverse of 4, what does it equal? 2? Or is it negative 2? And the idea of a function is you can't say it equals plus or minus 2. A function, your one input should give you one output. In other words, what you put in, you should be able to know what you're going to get out of it. And here we don't. There's two options. And well, how do we choose between this one or that one? So here, the inverse doesn't have, it's not a function. Now, I want to point something out. Notice that this fails the vertical line test, but I just want to point it out for now. If I put a horizontal line through x squared, well, of course, the horizontal line intersects here and here, intersects it twice, more than once. So let me do this again with a slightly modified version of x squared. For x greater than or equal to 0. Well, again, we say y equals x squared, x greater than or equal to 0. We swap them. Well, we'll keep this. We'll keep the bounds off for now. We'll leave that off for now. And then we square root both sides. Well, we could actually keep this. Say it's y greater than or equal to 0. That's okay here. Square root both sides. We'll get square root x equals y. Now remember, y is greater than or equal to 0. So that means this plus or minus, we usually put plus or minus here. Y is bigger than or equal to 0, the minus goes away. We just have the plus root. And so we get f of inverse of x equals the positive square root of x. Now, let's graph this using, again, just that positive root. Now f of x is x squared greater than or equal to 0. And then square root of x, the positive root, and here, let me put f of x here. That's f inverse. So what happens here, we do pass the vertical line test. Any vertical line I put through here only intersects the inverse once. So here the inverse is a function, but also note if I put a horizontal line anywhere through f of x, that horizontal line also will only intersect f of x one time. So here's the thing. Here's sort of the pattern. If the inverse is in fact a function, then the original function, f of x, will pass what is called the horizontal line test. That means a horizontal line will only pass through f of x one time. Sorry about the little rise there. So the horizontal line test says is this. If f of x is anywhere intersected by a horizontal line only once, and this is, I should say, everywhere, instead of anywhere, everywhere. Then f inverse is a function. So for example, if you have, say, like an oscillating function like this, if we pass a horizontal line through this function, even though itself is a function, it'll pass the vertical line test just fine. So it is a function, f of x. But if we take f of x and we pass horizontal line through it, and that horizontal line intersects more than once, the f inverse, this is f, the inverse is not a function. On the other hand, if we graph a function f of x like this, and no matter where we put a horizontal line, that horizontal line only intersects f of x once. Well, this says f inverse of x is a function. And that's it. So any questions, let me know, but that's pretty much it for inverses. And other than that, have a wonderful evening.